In this video, we will be talking about intervals of real numbers, all sort of real numbers. I'll define all sort of intervals for real numbers. So first of all, let us pick 2 points. Okay, so let A and B be 2 real numbers. Okay, be 2 real numbers. Okay, so now when I have 2 real numbers, I can make an interval out of it. So first of all, let me define for you what is an open interval. Open interval. Now an open interval, essentially, we've seen it many times, okay? Something like this. It looks like this. How do I define it? So to define a real open interval, AB, okay, these are called open brackets. How do I define it? I define it as all the x's. It's a set of all real numbers such that those real numbers lie strictly between A and B. Okay, those real numbers lie strictly between A and B. So for example, if I have a real line like this, from this end it moves to minus infinity, from this end it is moving to infinity. Now A and B are 2 real numbers like this. An open interval essentially is an interval which contains all the numbers between A and B excluding A and B themselves, okay, excluding A and B. That's what is an open interval. Now, let us define closed intervals. Closed intervals. What happens in closed intervals? A closed interval look like this. Okay, it's denoted as these strict brackets. And what is the meaning of these brackets? These brackets essentially tell us that closed interval is a set of all real numbers that are between A and B, again, just like the open intervals. But what is something that you need to know about closed interval is that in the open interval, we were excluding A and B. Okay, so this is a number A on number line, this is a number B. Now, when I'm talking about a closed interval, I'm talking about the fact that I am including A as well as B in this interval. So it also includes the end point. So closed interval includes the endpoints, okay? A and B are the endpoints of these interval, and closed interval includes the endpoint. Open interval will not include the endpoints. Now, similar to these two, we can also have combination of these intervals. So we have half open intervals that are half open. So intervals that are half open might look like closed at one end, open at one end. So it might look like this, or it might look like this. Okay, now what do I mean by this symbolization? What do I mean by this symbolization? With this symbolization, I am actually denoting the set of all x's such that x lies between A and B, and x can be equal to A also, because it's closed at this end. It's closed at this end, at the end of A. Okay, so it is including one endpoint and not the other. So this is A, this is B. It's including this endpoint. It's not including this endpoint. Okay. So all the numbers herein are in this interval including a. Similar to this will be the other half open interval. What will happen here? You will include all the x's between a and b, where x can be equal to b but not a. Okay, so we are including everything from a to b. A to b, it's open at a and closed at b. Okay, open at a and closed at b. So these can be two half open intervals. Okay, half closed, half open. So the length of each of the above interval is b minus a, though the length of each interval is b minus a, length of these intervals. Okay. Now, similar to this is a concept of infinite open set. Infinite open set can be of this sort. Okay, this is a real line. This is a real line. So what can be my infinite open set? If I have a set starting from a and moving to plus infinity and moving towards plus infinity. Similarly, I can also have an interval that starts at minus infinity and stops at a. Okay, so what are these two type of intervals? A to infinity, minus infinity to a. Okay, so this includes essentially all the points, all the real numbers greater than a. Everything greater than a is included here. And what is included here? All the real numbers less than a. Less than a. All the real numbers less than a fall into this interval. Okay. Similar to this, you can also have infinite. Okay, did I write what we call it? We call it infinite open interval. Infinite open intervals. Now, similar to this is a concept of infinite closed interval. Infinite closed intervals. Just think about what these intervals will look like. They will look like something of this sort. So if you have your number line starting at a, moving to infinity, so interval that includes a and above, okay, will be called infinite closed intervals. So interval that will include all the real numbers greater than or equal to a. Okay, they can also be equal to a, will be an infinite closed interval. And similar to this can be, this can't be. At infinity, of course, you have open end. Okay, so all the real numbers such that x is less than or equal to a will be an infinite closed interval. So on the number line, of course, you can see. On the number line, of course, you can see what we are talking about. We are talking about interval starting from minus infinity to a, including a. So all the real numbers less than or equal to less than or equal to. Now, so this is the reason why, once you know what we are talking about when we are talking about intervals, complete R, the real line can be denoted as an open interval minus infinity to infinity, an open interval minus infinity to infinity. Though R is something which is called both closed and open. R is something which is called both closed and open, and there is a particular reason behind it which we will discuss somewhere later in our course. Okay, a real line is an open interval minus infinity to plus infinity because minus and plus infinity do not belong to R. But still, I am quoting it that R is called both closed and open, and there is a particular reason behind it which we will discuss later.